Good morning, everyone. My name is Arslan, and you are watching Proper Pariksha, the place where we strive for academic excellence in a simple and comprehensive manner. So, today we will be starting the topic of proper fractions. So, what is a proper fraction? That is the question, and then we will come to certain examples and we will understand the concept in full detail. So, previously we have discussed about the fraction, what is it, and what is a numerator, denominator, real life examples, and what is the difference or similarity between 4 upon 4, 3 upon 3, 2 upon 2, and 1 upon 1. We exercised 7.1 and we discussed how to represent fractions on a number line. In the same video, we tried to discuss the concept of three different concepts which are not mentioned in the NCERT but they are given by me. That what are the three principles or three things you should have, three basic rules you should know about fractions, and what do they mean and what do they imply. So now coming to the topic of proper fractions. So first of all, we need to understand the definition of the proper fraction. So proper fraction is a number representing part of a whole. As simple as that, this definition is the same as that of a fraction which we learned in the first video of class 7th, class 6 mathematics chapter 7. In a proper fraction, the denominator shows the number of parts into which the whole is divided, and the numerator shows the number of parts which have been considered. So the thing is that the definition as per NCERT is not that accurate and is too much to write. Proper fractions are basically fractions in which numerator is less than or equal to denominator. Numerator is less than or equal to denominator. For example, 3 upon 4, 19 upon 20, 30 upon 41, 1 upon 2. So these are proper fractions in which the numerator is always less than or equal to the denominator. And if something is like 3 upon 2, then this is not a proper fraction. These are the proper fractions. Okay, so this is the simplest definition which you can understand, but for the sake of your exams, your class exams, you can write this particular definition as it is mentioned in the NCERT. So example number 1, to understand the concept of proper fractions in much more detail. So this question gives us the task of making a proper fraction using the denominator and numerator provided in the question itself. Just you can rewind it 10 to 20 seconds and you will see that the last line is mentioned that numerator is always less than the denominator. That is the main point of proper fraction and it should be mentioned in the first instance. Rather, it has been mentioned in the later part. So NCERT, this is the way of teaching and this is our way of teaching. So give a proper fraction whose numerator is 5 and denominator is 7. The thing has been mentioned as clearly as possible and you just have to obey the task. Numerator is 5, denominator is 7. What else can you do? Give a proper fraction. I have given it. Whose numerator is 9, whose denominator is 9 and numerator is 5. So 5 upon 9. It is already a proper fraction. Answer achieved. Whose numerator and denominator add up to 10. Okay. How many fractions of this kind can you make? So in this question, the task has been given that you have to choose a numerator and denominator who sum up to be equal to 10. So you can write 1 plus 9, you can write 2 plus 7, you can write 3 plus 7, you can write 2 plus 8. We'll go sequentially, that will be much better. So 1 plus 9, we'll go 2 plus 8, we'll go 3 plus 7, we'll go 4 plus 6, and we will go 5 plus 5. So you can just use the following and make 1 upon 9, 2 upon 8, 3 upon 7, 4 upon 6, 5 upon 5. There is also one more, that is 0 plus 10. So 0 upon 10. Do not write 10 upon 0 because of the rule mentioned earlier. 1 upon 9 can also be written as 9 upon 1, but since we are to make proper fractions only, therefore this is the set of proper fractions. However, if the question would have been how many fractions could you make, then we'll have 9 upon 1, 8 upon 2, 7 upon 3, 6 upon 4, 5 upon 5 is same, so it cannot be repeated. 0 upon 10 will repeat into 10 upon 0, which will not make a fraction. So this will give the same result and this will not make a fraction. Therefore, the total number of fractions are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Therefore, 10 fractions can be made in total, but only 3 and 6. Only 6 are proper fractions. Coming to the next part, whose denominator is 4 more than the numerator. Give any 5, how many more can you make? Okay, so another task has been given that the denominator should be more than 4, more than the numerator, that is, the denominator is equal to n plus 4. Denominator is equal to numerator plus 4. So take any number and make a number. So for example, I take n is equal to, if n is equal to 1, then we will have 1 upon 5, because denominator will be 1 plus 4, that is 5. If n is equal to 2, then it will be 2 upon 2 plus 4, 6. If n is equal to 3, then it will be 3 upon 7. If n is equal to 4, then it will be 4 upon 8. If n is equal to 5, then it will be 5 upon 9. So you can make as many as you want. You just need to put the value of n, that is numerator, and using the formula that is derived from the question itself, you can make as many fractions as you want. Now the second question asks us, a fraction is given. How will you decide? Just by looking at it, whether the fraction is less than 1 or equal to 1. So the thing is that it is testing your concept of proper and improper fractions. Improper fractions will come later on. For proper fractions, that is, that if the numerator is less than equal to denominator, or you can remove the equal to sign, you can just keep the less than sign. If less than denominator, then it means that it is a proper fraction. Similarly, it is less than 1, because that the total number of parts that have been taken in the numerator are from the denominator and not more than that. If numerator is greater than denominator, that is improper fractions, then it will be greater than 1. And if n is equal to d, then it will be equal to 1. Okay, so it will be equal to 1, and that means that 10 upon 10 will be equal to 20 upon 20, will be equal to 3 upon 3, will be equal to 100 upon 100. So these will all be equal because they all are equal to the value of 1. So this is something which you need to understand and make a note of, these three things along with the rules mentioned previously. So see that I have mentioned the concept of improper fraction beforehand, before the topic came, because I want you to get briefed about some topics, or you should know at least the name of that topic or that concept beforehand, so that when it comes under question and when it comes to make you understand or make you practice, then you are not afraid of the question and have some familiarity with the concept or topic itself. Okay, the last question remains, that is, fill up one of these using either of the comparison signs. The comparison signs has been discussed in our comparing numbers chapter, and you can see that video and see the chapter and you will understand it in much more clarity. So 1 upon 2 is, we'll just make it 1. We'll make all of them where the denominator is not mentioned. We'll just add 1 and we'll add 1. Okay, so 1 upon 2 is what? Less than or greater than or equal to 1. Simplest method is that numerator is less than denominator, that is, it is less than 1. So therefore it will be less than 1. 3 upon 5, numerator is less than denominator, so it will be less than 1. 1 upon 1, 7 upon 8, numerator less than denominator will be less than 1. Therefore, 4, you see that since 7 upon 8 is less than 1, but since it is written on the right side, the sign which is to be taken has been reversed. So this sign is read as 1 upon 2 is less than 1. This is read as 3 upon 5 is less than 1. This will be read as 1 is greater than 7 upon 8. And 4 upon 4 and 1 upon 1 are equal. As you know, we have discussed over here. 2005 and 2005 is equal to 1. This will also be equal to 1. So in the next video, we will be dealing with the concept of improper fraction and mixed fraction. So if you like our series, if you like our way of teaching, do hit the subscribe button and like our videos. If you have any suggestions for us, or if you want any particular topic to be made much more clearer, you can comment in the comment section, and please share with your classmates in case you find it useful. So in the next time we meet with the improper fractions. Goodbye.